Good morning, everybody. Welcome from Long Island Sound. It's Callie.
Hi.
And Debbie. And Captain Ian. We're aboard Fluke this morning. We're going to be doing a little bit of sampling in Long Island Sound. I'm going to give you a little tour of where we are right now. So if you look out into the distance, I'm looking directly towards the race, or the entrance to Long Island Sound. Over this way, you could say way off in the distance, that's Ledge Lighthouse. I'm going to zoom in on it for you. There's Ledge Lighthouse in New London. Over this way behind Callie is the entrance to the Thames River, the mouth of the Thames River. You can see right over this way is that's the lighthouse, the New London Harbor Light. So the Thames River begins just around the corner here. And then over here is Avery Point in Groton, Connecticut. So we're aboard Fluke. Once again, this is Debbie and Callie. We're going to begin some sampling. So the first thing I want to show you is this piece of equipment here. We're going to start, oops. Try to do the pinch zoom and it's not working. So I'm going to take a step back so Callie can show us this piece of equipment here.
All right, so while I tell you a little bit about this piece of gear, I'm wondering if anybody has any ideas what this kind of gear is used to catch. I'm going to talk a little bit about it and might give you some clues, but if you have an idea, send your message in the comments and we'll see if you're right. So this is a piece of what we call static fishing gear. It's something that we have to bait, and so if I open up the top, you can see that we've got bait right inside, and so that bait is going to attract animals to come into this trap. This trap has some heavy bricks in it, so it's weighted. It's designed to sink all the way down to the bottom of Long Island Sound. And of course we want to be able to find that trap again, so you notice this nice blue line that we have, and it's attached to our buoy. This buoy is going to be floating at the surface of the water once we get this gear set, and our Project O colors here are this blue and white checkerboard pattern. That's how we can find our gear, and we know it's not somebody else's while we're out here. So again, that bait is what's going to attract those organisms to come in. If you notice right here, we call these the heads or the gaskets. This is the opening that allows those animals to crawl right inside. They're attracted to that bait, so that's what they're going to go after first. And so this first section of the trap is what we call the kitchen. And after you have a meal at your house, what room do you go into next? I bet some of you are saying the living room, right? And so when we look at the second part of our trap here, that's exactly what we call it, the living room or the parlor, kind of an old-fashioned name for living room. There's a netting that's kind of in a ramp shape here. You can see my hand touching it now. So once those animals feed, they kind of walk up the ramp and then fall into that second part, or that living room section. And that's usually where they get stuck. Most of them will hang out there. We do have a small opening called the escape hatch or the escape vent, and that allows smaller organisms or our smaller target species to come out. Although you'll notice that ours is covered up right now. At Project O, we're not feasting on anything that we catch in these traps, but we're actually collecting these animals and collecting scientific data on them. So we're collecting animals of any size, and that's why you see our escape hatch covered up right now. Did we have anybody guess, Debbie?
I haven't seen any come up on the screen yet. If you think you know what this equipment is designed to catch, go ahead and put it in the comments. So Callie gave us a couple of hints. Right? She said this part here is intended, I don't know if you could see where I was pointing, is intended for animals to walk through. So whatever we're catching is a crawling animal. Mm-hmm. Callie, did you say where in the water we're going to put this?
Yeah, we're going to send this all the way down to the bottom. Remember those heavy weights that we have on the trap? Mm-hmm. So when we push this into the water, it's going to sink all the way down. So that's the benthic zone or the bottom zone. So this animal, this creature, lives down there.
Okay, so animal on the bottom that crawls around. Oh, and it must like to eat things that it finds down on the bottom. What's in our bait bag today?
It looks like we've got some fish here, and so these animals, you might call them scavengers. They are able to, wouldn't pass up a free meal, let's say that.
All right, so I haven't seen any guesses yet. Go ahead, post those in the comments. There's a little bit of a delay, so we're gonna wait and see what we see. Oh, Zach from Cranston says crocodiles.
Oh, Zach, nice guess, but nope, this is not crocodiles. Remember, we're out here in the estuary. This is brackish water, so that might be another clue. That means it's a mix of fresh and salty water.
Oh, I love estuaries. So fresh and salty water mixing. What kinds of animals? Oh, maybe a lobster. If you guessed lobster, you're absolutely correct. This is designed perfectly for catching lobster. They like to munch on that extra food that they can find in the bait bag. And then once they end up in the parlor, it's really hard for them to find their way out again. So we'll be deploying that at the end of our video today. But we kind of want to know why this is a good spot to find lobsters.
Yeah, so when I think about lobsters, I'm thinking about them living on the bottom, usually in a rocky kind of area. So Debbie showed you out over here off the coast of Avery Point. There are lots of rocks, and those continue into the water. And that makes a great spot for the lobsters to hide out. They can kind of hide in between the cracks and crevices of those rocks, or maybe in a little cave, and that helps to protect them from predators. So it's a really nice place for them to hide out and to live.
Is that all we ever catch in there, Callie? Just lobsters?
I wish we could only say that, but oftentimes there are other animals that end up in the trap as well. We call that bycatch. And sometimes we end up with things like crabs. They're scavengers too, so they're attracted to that bait. Once in a while we catch fish, sometimes even hermit crabs, or if we're lucky, something like a sea star.
That would be really cool. So Callie, I can't see all the way to the bottom here. How deep are we going to put this trap?
All right, well, I have some other gear with me today, and I want to show you some pieces of equipment. The first one is old school. We're going to show how to work this piece of gear. We call it a sounding line. It's not very high tech, but it gets the job done. This is a heavy weight attached to a string, and so you're going to watch me as we put this over the side and keep track of these knots. Each knot is representing about 1 meter of depth, and I'll be able to feel this hit the bottom, and you'll notice my line changes. So come on over. So here goes the weight. You may see those knots going into the water to start. Don't worry about counting them now. We'll count them on our way back up. So right now my line is tight. It's going straight down. I'm going to keep doing that until I can feel it kind of hit the bottom. Oh, there we go.
Oh.
So hit the bottom, and if I kind of let go, can you see how the line gets loose?
Yeah.
We call that slack. So I know that's how I'm at the bottom. So right now, perfect. I'm right about at 1 mark. So as we pull it in, Debbie, will you help me count?
Absolutely. So that's our 0 knot.
So
1, 2, 3, 4, 5, 6, 6. All right, so 6 knots, and every knot is 1 meter. So we're in 6 meters of water. There's 6 meters underneath our boat right now. So how deep is that? I'm used to thinking in feet.
I know, probably most of you are at home as well. So let's do a little estimating. We can say about 1 meter, or 1 meter is about 3 feet. So 3 times 6. Anybody got it?
Anybody got your 6 tables?
Anybody?
We gotta wait 20 seconds.
All right, so 6 times 3, we're in about 18 feet of water, okay, just to give you an idea. Now, that's going to give us depth. I brought some other gear with me if you want to take a look at it. All right.
Ooh, what's that?
So this is what we call the Secchi disc, or the Secchi disc. This is going to help us figure out the clarity of the water. When you were looking over the side with me, you couldn't see all the way down to the bottom. This is going to help us figure out how far our eyes can see into the water. And so probably our prediction is this won't make it down to the bottom before this sort of black and white pattern disappears. We've got those same yellow knots in this line, but also we have some blue marks on here as well. So we're going to be measuring to the nearest quarter meter this time. So let's see what we can figure out. Come on over to the side again. All right, so just as I put this in the water at the surface, can you see that sort of black and white pattern?
Yeah, very easily.
Current's kind of taking it a bit here, but I'm going to continue to lower that until we can't see that pattern any longer. So this is about 1 meter. You can see the white background looks kind of greenish today, actually. Let's keep going.
Callie, why is it green?
Well, there's a lot of stuff in this water, a lot of living things.
It wouldn't be plankton, would it?
It would. Lots of plankton in here. So much, in fact, it does affect the color of the water and the sound. So this is 2 meters. I can still see it. How about
Easily.
you guys at home? Okay, let's keep going. Let's try another meter. Okay, so this is 3 meters. It may be hard for you to see, but I can still make that white out. Okay, good.
How about my viewers? Can you see the Secchi disc?
All right, we're going to keep going deeper. This is 3 1/4 meters.
Ooh.
It's getting harder, but I can still make it out.
I can barely see it.
3 1/2.
Oh, I think I might have lost it. Can you still see it, Callie? Oh.
Let me go one more just to make sure. This is 3/4. 3 3/4. Up. I think I don't see it any longer.
I don't see it anymore.
So 3 3/4 meters. Okay, and that's where it disappears. As I start to pull it up, you'll notice that bright white color, easy to view again, until we take it all the way out of the water. Okay, excellent.
Pretty cool. So we could see 3 3/4 meters down to the bottom, and the water is about 6 meters deep. So we could see more than halfway through the water column.
Yeah, that's pretty impressive.
So if I were a lobster down at the bottom, I'd be seeing sort of a darker green, right? It would be kind of hard to see. So we're going to take a minute here and record some of the measurements we just took. So we took the depth, that's going to be 6 meters. And our clarity is 3 3/4, or 3.75 meters. So we'll record that as some of the bottom conditions, where we're going to put our trap, the kinds of things that we're going to measure down there. Now, if I were a lobster, there's some other conditions that I care about too. So I'm going to give the camera to Callie. Oh, wait, hold on.
No.
I'm getting ahead of myself here. Callie has one more piece of equipment first.
All right, so I want to show you one more piece of gear called the Van Dorn bottle, and you're noticing I'm putting my cork or my plug in right now. This is a device that's going to allow us to collect a water sample from a specific depth. Since we're talking about lobsters today, that depth is the bottom. So I'm going to send this all the way down to the bottom with these plungers open. Since it'll be underwater and you won't be able to see sort of the magic happen, I'm going to show you an example of what that looks like now. So I'm going to open up both plungers. My cork is in. When this bottle goes underwater, water will be able to fill this tube up. When I send it to the bottom, if I only want bottom water, what do I need to do? Close these up, right? Debbie, did you remember your snorkel gear? Are you going to be the one to dive down and close up the plungers today?
Oh, I thought you were going to do that.
No, I forgot. Don't worry. We've got a plan. We have a weight. We call this the messenger weight, and so we actually don't have to go in the water today to make this piece of gear work. Make sure they've got a good view, Debbie, because this weight is heavy. When it hits this little peg, you're going to notice that the plungers close up. Here we go.
Whoa!
Yes.
And then all the water at the bottom will be trapped in there, right?
That's right, and all we have to do is haul it onto our boat. We take our cork out, and then we can fill up our bottles, okay?
Awesome.
So step 1, collect our water sample. Step 2, we're going to do a little temperature measuring and salinity measuring with that. So let me get this ready again. This time we'll deploy it actually to the bottom.
6 meters down, right?
That's right, where we expect those lobsters to be hanging out. All right. So here we go. Into the water it goes. Again, my line is nice and tight.
It's hard to see on this camera, but there are little marks on this line, so Callie knows how deep to send her Van Doren bottle.
That's right. And it's also weighted, so that helps it to sink straight. We're here at anchor, so that's helping us too with any currents in Long Island Sound today. Okay, so here we go. I'm right at the bottom. See the messenger weight? Is that in your view?
There it is.
Okay, so here we go. We'll send that down. Whoop! Kerplunk.
It's like you're really
The bubbles are going out. And
nice.
now we'll pull this back on board.
So even though we couldn't see it, those plungers closed around the Van Doren bottle, and we're bringing a sample up from the bottom. If you're just joining us, hi Alana. This is Callie and Debbie on Fluke Gathering Long Island Sound.
All right, so let me get my sample bottles. I'm prepared with my foul weather gear today, so it's okay if we get a few splashes here.
All right, so Callie's filling from the Van Doren bottle. This is water from a depth of 6 meters. Oh. So the first thing I want to do with this sample while she's filling that second bottle is I'm going to take the temperature of this water. All right, so I have a thermometer here, and it measures in Celsius, right? Because we're measuring in Celsius. We're scientists, we measure in Celsius. So I'm going to drop that right into the bottle now, and we're going to let it sit there for a minute or so. So I'm confident that it's measuring the temperature of the water and not the temperature of the air right now. So Callie's filling her second bottle, and we're going to do a second test with that.
Okay, I'll pass that to you.
Okay, Sable wants to know, how many lobsters do you normally catch in the trap, Callie?
Oh, great question. We have a study that we do in the summer with summer campers, and usually we set 10 traps out at a time, and we try to pull them every day. This is during the summer, and we're really happy when we see, honestly, any lobsters. Sometimes we've caught as many as 5 or 6 in one trap. Sometimes we catch none, and sometimes we only catch one. It really depends.
All right. So I need 2 hands to sample the salinity, so I'm going to pass the camera off to Callie. Hi, everybody. All right, so I have my sample bottle here. Remember, 6 meters of water. Hi, Johnny. So this is an instrument called a hydrometer, and this is going to measure the salinity of the water for us. I'm going to pour it in the top, and this needle that's in the middle here is going to respond to the density and the salinity that's in this water, and the needle will point to my salinity. So I'm going to do that now without pouring too much onto myself. Gurgle, gurgle, gurgle.
Okay.
All right, right up to the top.
Yep.
It's got a little overflow
We
valve.
can see that needle moving.
All right. So if I'm a lobster and I'm going to come into this trap, I want to know what kind of conditions these lobsters are experiencing. So when I think of lobsters, I think of Maine. And the water in Maine is cold and salty. So we're going to see if that's what we're experiencing today. All right, so I'm going to try to hold this as steady as I can. Callie, are you able to read any of those numbers?
Yep, when we zoom in here, can you guys all see at home? We are about 29 ppt or parts per thousand, just shy of 30.
All right, so 29 ppt. I'll write that on my board in just a minute, but what does that mean? 29 parts per thousand. So let's put it this way. If I wanted to make a model of our estuary, I would take 1,000 cups and I would fill 29 of them with salt, and the rest of them I would fill with water. So that's about how much salt is in our estuary right now. We said that an estuary has brackish water, or a mixture of salt and fresh water. Our salt water is coming from the Atlantic Ocean, just to this side of me, and the fresh water is coming from the Thames River, just to the right of me. So we have a mixing here. To put 29 into perspective here, the Atlantic Ocean averages about 35 ppt, or parts per thousand. So we're a little bit fresher than the ocean here, and that's to be expected. So we know that lobsters like salty water, and we can kind of check that box. We can also take a look at the temperature, right? So I was able to get just a quickie view of this. I don't know if you're able to tell at all, but if I look at that, we are just underneath 10 degrees Celsius at the bottom. So
Okay.
Not as cold as I was expecting, honestly, but still pretty chilly down at the bottom. So our formula for Celsius to Fahrenheit conversion is 9/5 plus 32. So we'll do 10 times 9 and then divided by 5. Do I have any math whizzes at home who want to do that equation for me? No? Nobody? Okay, 10 times 9 is 90. 90 divided by 5 is, I have to think for a second, 90 divided by 5. Well, I can break it down. My 5's tables, I know 5 times 10 is 50, and 5 times 11 is 55. Anybody got it at home yet?
Not yet.
No? And then we're going to add 32 to that final number. So I was kind of surprised to see it's already 10 at the bottom in this part of the estuary.
Yeah.
Any math whizzes?
Ooh, 50 we have.
50. 50 Fahrenheit? That's pretty warm for beginning of April.
Yep.
So I'm pretty glad to see that. It's chilly though, compared to anything that you'd want to swim in. Lobsters might like it a little bit cold, but it also causes them to move a little slower. Every process in their body slows down when it's cold. So when they're walking, it takes them a little bit longer to get somewhere. So we're going to leave this trap in until next week. All right, so I'm going to record.
Oh, great idea. Let's record.
Record our temperature, right? We said that it was 10 degrees Celsius and it was 29 parts per thousand salinity. All right, so these are the conditions. We're going to compare these to how many lobsters we catch in our trap next week. I think that these look like pretty good conditions for lobsters. So
I agree.
I'm hopeful that we're going to be all right. I'm going to get ready to deploy this trap. It's already got its bait in it, and I'm going to use the bungee to keep it closed. Okay, and remember, Callie said it's pretty heavy here. We got 4 bricks in there. So the first part that I'm going to put out is our buoy and then our buoy line. It's got to be as long as the depth of the water, but it's going to be longer than 6 meters today because the depth here changes. What kinds of things might change the depth of the water in an estuary?
Oh, if you caught our Rocky intertidal.
That's right. You'd know all about tides, right? So as the tide comes and goes, the depth of the water is going to change out here. So I need my line to be longer than the water's depth at high tide. Okay, so we're going to put that out. I'm going to throw it a little ways from the boat.
Okay. That buoy's doing its job. You can see our blue and white checkerboard
flag. That's okay.
Floating at the top.
Ooh.
All right.
It's a little tangled here. I'm going to untie it.
Yep, so we're just making sure that there are no tangles in our line. We wouldn't want any knots in that line. So Debbie's working to make sure that's running free. And once she has that clear, then she'll just be able to push that right off the bow of our boat into the water and down to the bottom of Long Island Sound.
There we go. Just kind of wrapped around itself a little bit. All right. And we'll see this trap next week. Hopefully with some lobsters.
That's right. Woo! There it goes.
All right. Well, thanks for tuning in, everybody. We'll be back live on Thursday with Marissa and Kyle. Thanks for joining us on Long Island Sound.
And don't forget, check us out on Tuesday because we're going to be pulling those traps back in. All right. Thanks so much. Bye, everybody.